Hello everyone, welcome to Practical GCP. So today we'll be talking about how to get data from BigQuery into Datastore via remote functions. So these will be specifically on how to get the data from BigQuery as events into Cloud Datastore. So we start with a common problem and what are some of the usual ways to solve this problem. And then I'll talk about what is BigQuery Remote Functions, including some of the powerful libraries such as bigfunctions can help us to utilize this much better. I'll show you everything in the demo, and I really think this has a lot of possibilities we can explore. Okay, let's have a look at the problem. If you look at this diagram, right, this is a quite typical workflow. Imagine you have teams runs DBT, right? These are usually your analytics engineering analytics teams. They write SQL and then they do transformations on your data from the raw data, very, very messy stuff, into clean data models, right? But the problem is when you get to this stage, you can't really get these data models into what we typically call analytics operations, which is to get them into things like Cloud Datastore to serve API calls. So on the right-hand side, what this means is usually you have an API gateway, you have Cloud Run as your runners for your applications, and then you have websites and users. So these users accessing your website, go through your gateway, and then try to do some stuff, right? So these could be your data product and services. Then typically you need fast lookups to get the data from the Cloud Datastore service. The issue here is how do you get this data from here to here, right? So it's not exactly easy. And usually what happens is, I think I've actually talked about this in some of my previous videos, is you can put a cloud scheduler here and then run it every number of minutes, right? So this is typically a Cloud Run job. And then you do delta tracking via SQL, you check the timestamp to see what actually finished, when stuff changed over a period of time. And then you pull, right? You pull every few minutes. You get the data from the clean data models, fetch the delta, and then you push it into Datastore. So this is okay, but the problem here is, first of all, you have to run a schedule, right? And then secondly, if you are the team pulling data from, if you look at on the left-hand side, these are usually different teams, right? So the teams run DBT don't know how to run Cloud Run jobs, right? So they will give you some data, and then you typically have to fetch those as data engineers. You have to fetch those data and send it to Datastore. But you don't necessarily know, what is the partition key and how do you fetch the delta? So that's the domain knowledge of the teams running DBT, right? So we have a problem here, and then often you have the upstream teams and downstream teams can't agree on exactly how to fetch data, and then either you could lose data or you actually run into issues, or just couldn't reach out to agreement on exactly how to do a proper data tracking. In addition, there's another problem here, is you always introduce latency, right? Because you have a cloud scheduler here and you run it all the time, you always worry about the cost here, how much scan you do, but it always adds a latency, right? So either you run it every few minutes, this still adds a few minutes latency on top of that. And then if you think about it, if you write this into another BigQuery table for a different team, then you add just more latencies after that as well, right? Okay, so what if, right? What if we have a way to, let's say that when the teams that runs DBT produce the clean data models, they, right, instead of you go and pull the data, they have a way to send this data they actually just track. Let's say they do a DML merge on the DBT, and then they have generate some deltas, and how to actually send these deltas, maybe in the form of events, into Cloud Datastore directly, right? Directly from DBTs, right? No other process in the middle. How do you send this directly into Datastore? Okay, this is what BigQuery Remote Functions comes in. So it's not exactly true, there's nothing in the middle, but there's pretty much very, very minimum things you have to maintain. I'll go through this later, especially with this thing called bigfunctions, and I'll show you exactly how this can help you. So a BigQuery Remote Function lets you incorporate Google SQL functionality with software outside of BigQuery by providing a direct integration with Cloud Functions and Cloud Run. So right, And basically what it means is you can run some SQLs, right? And then it's basically like a function. You run some SQLs as a function, and then those SQLs, right, you run can actually send events, right? When you run the SQL, it actually sends events into Cloud Function endpoints or Cloud Run endpoints via HTTPS request, right? That's what this thing actually gives you. And to make it a bit easier to understand, right? So this is what you actually get. So instead of, if you remember the previous diagram, we have a question mark in the middle and not exactly sure how to get data from the data models in BigQuery into Datastore. So here, what happens is you write some SQL, right, to generate to create a remote function, and then you get the data out, and it can directly send into services such as Cloud Run, right? And after you send this to Cloud Run via like parallelized HTTPS requests, and these can also write into Cloud Datastore in parallel. So the bottom here is basically a screenshot of example of what a remote function could look like, right? So you have an ID of the function, and then you have things like this, right? So you have arguments which you can specify because this is specifically created for Datastore, right? So you have a project ID. This is your GCP project. You have a Datastore namespace, Datastore kind, which one you want to use as a key, and finally a JSON data type, right? A JSON data type which contains the key value pairs of all of your columns that you want to send. And then this bit is quite interesting as well because you specify, right? You specify the endpoint of the Cloud Run endpoint, right? You see, this is the endpoint I've deployed as a Cloud Run endpoint. Then basically you can actually call this function and then data will be sent to this Cloud Run endpoint. So this is how it completes this flow. Big functions. So initially I was thinking about doing this myself, creating a Cloud Run endpoint and then getting the functions in SQL to do all of this from scratch. But this library called Big Functions, right, is a collection of libraries, but also deployments to help you to do a lot of these things automatically, right? You don't have to start from scratch. It has a very rich collection of libraries to help you. So let me give you a quick tour of this at a high level. If you look at this is the kind of the homepage of Big Functions. You have a collection of many remote functions that you can deploy to do different kind of things. So this could include things like getting data, notification. You can send Slack messages, right? You can export. This is where the Datastore thing we'll be looking at. You can send to PubSub. You can upload data, and then there's a bunch of things you can do with it, right? So, and the ones we are looking at today is specifically related to exporting data to Datastore. So this has a very easy form. I'm not going to go through how to use Big Functions in today's call because the instructions after I tried it is super easy, right? You can just follow these instructions. There's not much to do at all. But if you look at the export to Datastore one specifically, as you can see, this is very similar to the screenshot I provided in the previous slide. You get project, namespace, kind, key, and data, right? So these I explained specifically, and especially in the data side, is a JSON dictionary of data. So to make it a bit more easier to understand on this specific function, you can see this is the example here, right? You call a function with a select query. You say BigQuery dot, this is the region, and then the function itself. And you've got the project you put in and some of these other, the one mentioned above. And then finally, if you look at this, right, that's the JSON payload you put in. Obviously, this is just the example. And later on in the demo, I'll show you exactly what I did with some of the generation of large amount of records from a table and how could I send these to Datastore at scale. Okay, now I'm going to show you what I've done. So first of all, in order to use remote functions, this is, by the way, all done by part of the Big Functions library and deployment. So first of all, you need a connection, right? You need an external connection. This, when you're creating the external connection, it creates a service account ID. And this specific service account, you need to give it access, right? You need to give it access to the Cloud Run endpoint with the Cloud Run invoker role. So this is what it allows when you run the function to actually send data to the external service running on Cloud Run. And this one is the same as the screenshot I showed you earlier, and it is basically the function itself, right? This is the export to Datastore function. What I've done is, rather than earlier, this is just a demo. You wrap around some random strings into just sending one record. But in this particular one, I've actually generated lots of users. So in this particular case, I've generated 1 million records here. If you look at the preview, you can see these has the name, the email, the phone number, and address, right? And I've also generated another one, which is the unique records. And this comes down to the query I'm running here, right? Because I want to have a hashed version of the email, which I can easily do the lookup via the key, right, in the most efficient way. So this is the key I put into Datastore. And then finally, I'm converting all of the columns, right, combined as a struct, and then converting that to a JSON type. So this is what's going to come into the other side as a key value pair, like JSON payload. So you can see already, I ran this before. I've got 521,000 records written into Datastore. But let's try this again, right? So let's if I'm going to put into a different hash, let's say do number 10, right? So if I do this one again, and let's see how does this go. So right now, this should be sending to the backend, to the Cloud Run service. So you can see now it's actually scaling up and down, right? So this is the container, it spins up. So it's specifically in this case used for, if you look at the logs, now it should be running. So you can see here, right? So it's actually parallelized all of the BigQuery functions requests. So because we've got 500,000 records, right? So it parallelized a lot of this request to the Cloud Run endpoint to send it in parallel, right? This is very powerful. If you look at the metrics, you can see now this is scaling up, right? This is scaling up. The CPU is going up, utilization is going up. Here, you've got the number of workers running. This has a bit of delay, but later on when this is scaling up, and then you will be able to see that you see the number of concurrent requests going up, right? So that's all going in parallel, writing into Datastore, right? You can see each batch is taking about 5 to 6 seconds for 1,000 records. So the batching is automatic. So there's things you can tune on how you want the batching behavior to operate. But a lot of these requests you can batch rather than just sending it one request at a time, right? So what we've done is, this is finished already. So that's pretty quick. So you can see this whole thing took only less than 2 minutes, right? So, and this one we have not even scaled up. We only had, I think it's 16 Cloud Run instances in total that we were sending. And if you look at the email hash 10, right? So refresh this page. And if you look at email hash 10, so I've been doing a lot of testing earlier, and then we do a count. So you can see we've got 521,000 records. So this is like how it can actually send all of these records just purely using SQL with a function and into Cloud Run in an extremely scalable way, right? So when you run this, and imagine this is a analytics team, right? This is what the analytics team is doing. So because if they're using DBT, so this is not outside of the context of DBT. They created their data models. They now run this, right? They could do delta tracking. They produce some delta updates into their data models, and then they know how to track the deltas because they know the domain, right? Then they run this thing, put it on all of the delta. You can even do a full load because it's a fully scalable solution here. You can do a delta tracking, you can do a full load, and then all of these will go, in this particular case, into the output, right? So the output, you can see here, is all of the rows being written. So you can actually check what's been written in every time you run your job. So this is extremely powerful. So you can see in this query, every single row is an ID that returned from the Cloud Run API, right? So you can see this looks like the MD5 IDs for me, right? So that's for all of the 521,000 records. Okay, so this is how it works and how they can scale from just using SQL, sending everything into Cloud Datastore via Cloud Run, without leaving, without actually even involving another team to do anything, right? So instead of your data engineering team to go and fetch the data, you can deploy the infrastructure as a remote function, such as this, with the Cloud Run service at the back. Then you can get the analytics team running dbt to call it, right? So that's why this one is very powerful. So coming back to the slide, the reason I say the possibilities are endless is because of this. So now think about it, right? So the use case I described is about getting data, from the analytics teams, analytics engineering teams running dbt jobs into BigQuery and then put it into Datastore, right? But I expanded this a little bit. Imagine you have teams running dbt producing data models. You could have some other team, the data engineering team, running Cloud Run jobs and then fetching data from other places, putting some data models in BigQuery. You could also have Cloud Composer, maybe doing some ingestion, right? And then getting data into BigQuery. So all of these, when they land in BigQuery, you could actually deploy the remote functions to allow all of these data models, as soon as they land, to trigger events via Cloud Run, right? So those goes to Cloud Run, but importantly, I don't actually think putting it into Datastore is the best way to do it. You could do it, but I think there's a number of issues with Datastore because it takes time for Datastore to scale up, right? So it's not exactly this is instant. And then using BigQuery to try to send it to Datastore directly, doesn't give you the error handling you probably would like, right? So instead of doing that, but also there's other reasons, which is to unlock different additional use cases for different teams. So then you can trigger the remote functions and send the data into PubSub instead, right? So let's say the 520,000 records I've sent in there. Instead of sending to Datastore, I send it to PubSub. You can have one team subscribing to PubSub and consuming those records to put into Datastore for API serving. And again, because you have PubSub in the middle, you have automatic retries with acknowledgement, and then you can actually subscribe it and send. Sorry, I missed something in the middle. This one you need a Cloud Run service in there as well, but you get the idea, right? But you can have other team, right? You can have other team doing some enrichment of the same data and then putting into more data models in BigQuery for maybe reporting and other use cases. And even better, you could have a team managing the subscription of the PubSub messages using another Cloud Run service and sending to a subsequent PubSub topic, and that can be subscribed by other teams for the creation of other microservices. So if you think about this only thing, right, is all because you have this remote function to turn something in BigQuery via a SQL function into events, right? Because you can turn it into events, that means you enable all of the different use cases from different teams via a PubSub message queue in the middle, right? So from this point, everything else becomes subscriptions. So this would really allow you to create this analytics operation. So you're creating some data models, but then in reverse, you can utilize these data models for operations in many different use cases. Okay, let's do a summary of what we talked about today. So first of all, BigQuery Remote Functions can turn SQL into events via Cloud Functions or Cloud Run, right? So this is the thing that allows us to, rather than doing this scheduled pull job like what we used to do before, we create a remote function, we trigger it when via a SQL query, and then every single row is going to turn into events, and that will call the Cloud Function or Cloud Run endpoint, and it will become messages either into PubSub or into Cloud Run for downstream consumptions without anything in the middle. So keep in mind for big functions, right? In my opinion, you should really use this because starting from scratch is a lot of work using remote functions. But if you use big functions, it has a powerful collection of libraries and also deployments of your Cloud Run or Cloud Function services. This would allow you to send data that you have in BigQuery into many different places with very little work involved. So as I mentioned earlier, keep in mind, sending data directly into Datastore can potentially cause scaling issues because BigQuery doesn't have a great way to manage error handling. And if you run into scaling issues and things fail, it's not exactly easy to see what is going on. So sending something, the data into PubSub instead, which is much more scalable because it's a message queue, right? It doesn't do much. All it does is to receive messages. And then that can allow multiple downstream users, right, to build other services from the message queue itself. And finally, remember, I think this is probably better done as a pull request to the big functions library. Is when you deploy big functions with let's say a Cloud Run service, the Cloud Run ingress rule, right, is actually set to all. So that can be a security risk. So make sure in the meantime, and once you've deployed it, and change the Cloud Run ingress rule back to internal, because I've tested this out. You do not need the Cloud Run ingress rules to be all in order for this to work. You can set it into internal, right? So you can see what I've done in here, right? You go to networking, and initially this was set to all, but you can change it back to internal, which means it's only available in this particular case from the BigQuery traffic, right? It's all via internal Google network. It doesn't have to go public. If you enable it for all, anyone on the internet can see it. Okay, that's everything. I hope you found this very useful, and I'll see you next time.
Go out!